Understanding concentrations illustrates whether you've got a good understanding of equilibrium and acid and base reactions in particular. If we have a strong acid, for instance, it reacts completely producing hydronium ions and chloride ions, so there is no more of this species here present. Remembering that in any species you list, you must always include H2O, H3O plus, and OH minus. They are present in every solution. Okay. Now in NCA they often will say ignoring H2O because it's a given that that's always going to be the highest. So for this first one we would have H2O, then next we would have these two amounts being about equal, because if we have one of those it makes one of those and one of those, and that gets used up in that reaction. However, because there's already some hydronium ions present in the water, we'd say they're roughly equal. So we'd say H3O plus, and this is the approximately equal sign to chloride ions. And then of course we've only got one other species present there, and that's going to be the hydroxide ions. Now in the second one, these two illustrates how it completely ionizes in solution. So first you'd have water, and then you would have the hydroxide ions, which would be approximately equal to the sodium ions, and then you'd have H3O plus. Okay, now in these different cases of weak acid and weak base, if you're asked what happens when you put ethanoic acid and water into list the species in order, again you'd start with water, although again questions usually say ignoring that. Now remembering this is a weak acid, and the key here is that because it's a weak acid it mostly stays as a weak acid. Kind of think of it like that. There's 999 on that side and there's just one of each of those. So that means the next is going to obviously be CH3COOH, it's mostly present, and that's going to be greater than H3O plus, which is going to be equal to CH3, or approximately equal I should say, tiny difference. And then we're missing out one, the hydroxide. It's there but it's in very small amounts. Okay, so that's one. Second, what if we had a solution of the ethanoate ion? Well again that's a weak base, so again you'd have lots over here and hardly any over here. So because of that, first of all we'll have water, then we'd have CH3COO minus, and that would be greater than, well, hydroxide equals CH3COOH, and then again we're missing one, H3O plus. Notice you only list the species once. Sometimes students will list them more than once, say hydroxide, hydronium. The concentration can only be listed for once for each species. Third is a salt. Now remembering a salt has two reactions. First of all it ionizes to form two ions, and then in this case because one of those ions is a weak base, it's going to react to water to produce hydroxide ions in the conjugate acid. Now first of all obviously we'd have water, and then next, well, these two ions are roughly equal because it just ionizes. Now sodium ion will be about, now because the ethanoate ion hardly dissociates at all, it's probably about equal to the sodium ion. So you could say equals this, or you could say greater than, because it is the sodium ion, but it is a little bit more because it doesn't actually react with anything in water, whereas the ethanoate ion here partially dissociates just a tiny bit to produce some hydroxide ions and the conjugate acid here. So I'm going to put greater than, and then I'm going to have the hydroxide ion equal to, or approximately equal I should say, to CH3COH, and again I'm missing one, and that's the H3O plus if I can fit it in there. Okay, so that's another example of listing the concentration. Okay, another example, HF, weak acid. Now this is a key. You need to recognize whether it's weak or strong. If it's weak, the equilibrium is mostly on the left-hand side, the reactant side, and it does help sometimes to write the equation to make sure you don't miss out any species. So in this case, again, water, it's going to be greater than HF, it's going to be greater than H3O plus, which is about equal to F minus, and that's going to be greater than the hydroxide ion concentration. Now if it was something unusual like sodium chloride, well, that just splits up into, it's not in equilibrium, of course, it just splits up, it ionizes into sodium ions and chloride ions. So first would be water, then would be Cl- ions, which would be equal to Na plus ions, and then of course it's pH neutral, so H3O plus would be equal to OH minus. So that's just an unusual one to finish that off. Anyway, that's relative concentrations. You should be able to arrange them in order.